All right, so good morning or good afternoon, good evening, everyone attending the webinar hosted by GlycoSpot today. We've given it the title, Benefit from a Customized Mashing Process, and I think that very much covers that it's going to be a webinar in the name of brewing and malt quality to a large extent. With me today, I have our senior scientist, Raymond, and Raymond will happily be sharing his in-depth knowledge about enzymes, how enzymes work during the mashing process especially, and how measuring the enzymes during process can help in process optimization and also in understanding the quality of raw materials in brew even better. I think basically what we would like to achieve here from GlycoSpot side is to enlighten you on how the use of enzymatic test kits can be implemented very fast and easily in your companies. I think that's very much what we stand for, transforming the way you work with enzymes and making it fast to implement and easy to use. So we do that across the measurement value chain, and I think that's also going to be evident from Raymond's talk today. I think that's pretty much my introduction. I think with that, I'm going to hand it over to Raymond. Should you have any questions during the talk, there's in the right side panel, there's the possibility to ask questions. We will try to keep Raymond uninterrupted during his talk and take the questions towards the end. So I think with that, the stage is yours, Raymond, and welcome to all of you. Thanks.
Thank you, Jonas, for the introduction, and welcome everyone from all over the globe to this webinar regarding the benefits of a customized mashing process. Now I'm going to share some slides with you all so that you can better understand what we offer from GlycoSpot side. Okay, so now you should be able to see my presentation, which is titled Benefit from a Customized Mashing Process. And the agenda for today is we're going to cover several topics. First, of course, we're going to make a small introduction to GlycoSpot. Who are we as a company? Afterwards, we will also cover what are our methods regarding malt. And then we will jump into more specifically what is our applications regarding the mashing. After that, we will also share some success stories. In this case, we're gonna focus both more in malt and mashing. And at the same time, we will gonna have questions to be asked by you, the audience, and answers from us by the end of the presentation, as Jonas was saying. So who are we? Here today we have Jonas, who spoke a minute ago. He's the commercial director at GlycoSpot, in charge of commercial activities, as he presented himself. I am Raimon Pares-Viade, a senior scientist at GlycoSpot, I'm in charge of the development and commercialization of enzymatic assays for the malt and brewing industry. But we are not alone at GlycoSpot. We have other 14 employees who do an amazing job to help us develop and commercialize enzymatic assays for different industries. We are sitting in Søborg, on the outskirts of Copenhagen, where we have the lab facilities that we need to do all the R&D and production job. But we also have a very healthy work atmosphere in which we have a very good collaboration, and that's you can say the secret of our success is the good collaboration we have internally at GlycoSpot in between our employees. Now let's jump directly into some results. In this case, for malt and our method for malt. If we look at the value chain from barley to beer, as most of you know, the way or the steps in between are several, and they require several technical transformations of the grain. First, you have what you would call a malting process, in which the grain, in this case barley grain, germinates in order to allow the enzymes present in the barley to be active. This activation of the enzymes is the secret of starch conversion into sugars during the beer brewing. And as you all know, this conversion of the starch in the barley into sugars happens in the mashing step in the brewing process. But basically, from GlycoSpot side, we cover mostly the finish malt right after the kilning, that is after stabilization by heating up, which at the same time stops the germination. We also are able to measure activity of enzymes during the mashing step, but we also are able to monitor the enzymatic activity development during malt germination. Now let's have a look at our methods a bit more in detail. So basically, currently there are several methods to measure enzyme activity in malt and other grains. Those follow the EBC or ASBC standards. You can also use enzymatic kits that are basically do-it-yourself. These two processes, so the EBC or ASBC method, which is based on iodine and wet chemistry, or the enzymatic kits, they both require skilled personnel, they both require long hours of processing, and most of the times they are time consuming. An alternative to this is to send your samples to a research center, which will use the above mentioned methods. However, that is also costly in terms of money. Instead, what we offer as a kit is what we like to call a ready and easy to use kit in the proximity of the production that is also fast to produce. The kits that we are actually commercializing nowadays cover different products: barley malt, high diastatic power barley malt with malt, but also malt extract. And as we will see in the next slides, also mashing mashing wort samples. But basically, for barley malt, it covers it can measure both diastatic power and alpha amylase activities in the units that you desire, but also conventional units like Vindish Callback for diastatic power and dextronizing units for alpha amylase. I said before that our method is fast to use, but how fast it is? Well, it can actually measure up to 6 samples simultaneously. You would be able to measure in about 20 minutes. So from the mill malt sample to the result, it would take you 20 minutes for 6 samples. How would you do that? Well, first you will need to weigh 200 milligrams and extract 10 minutes with a buffer that we supply. After this extraction, there is a syringe filtration with, again, a syringe that we also supply. And then there's an incubation process in which we react the extract with the substrate that we produce ourselves. In this incubation, a color is produced, and depending on how much intense the color is, the more the color, the higher the activity. To quantify that, we have developed at GlycoSpot our own spectrophotometer. That has to do with the healthy work environment I mentioned before. And by using our own spectrophotometer connected to an app, you are able to get the results in an app for Android and for also iPhone. So from mill sample to the result in your phone, it takes 20 minutes. How accurate are we? Well, if we have a look at different ring trials we participated in, here I have a sample of some of them. So the dark lines represent the results of the ring or the reference values of the ring trials, and the gray values are the average or the triplet or the result of triplicates using our method. What we can see is that in terms of reproducibility, we are less than 20 Windisch-Kohlbach units away from the reference value, and 20 Windisch-Kohlbach is well below of the reproducibility criteria by EBC, which is defined by this formula. Okay, so for this range of samples, the reproducibility range would be something between 50 and 80 Windisch-Kohlbach, and we are well below with 20 Windisch-Kohlbach. When it comes to repeatability, again taking the EBC criteria, which would follow this formula, and repeatability would mean how good are you at repeating the same result with the same sample and the same method. What we can say is that with our triplicates that we measure here, we had all the values within or following this repeatability criteria, which in this range is between 15 and 20 Windisch-Kohlbach. At the same time, we can say that by the use of these kits, our customers are able to measure more samples, and that can entail a lot of benefits. For instance, they would be able to measure in every single batch. And why is it important to measure in every single batch? Well, because like in everything else during the malt production, there could be some issues happening. For instance, there could be a batch which have virtually no enzymatic activity, could be because of an excessive kilning or for different reasons. There could be also the fact that there's some inhomogeneities across different silo storages of the malt. So basically, most malt houses, they would mix different batches in one silo, or there could be variations from one season to another, or within the same harvest, there could be different inhomogeneities, or it could be a supply made to a customer in which several different malts are mixed. For whatever reason, there's the benefit of measuring in every single batch or in every single delivery or in every single mold that you receive as a customer or that you send as a customer. One example of this is a real case we made in the industry, in which we compared two samples that had the same certificate of analysis, in this case by using EBC methods. We tested with our method, and what we could see is that there was a clear difference between the two batches. One of them was 9% below what was certified or what was measured using the EBC method. The other was actually 24% below. We actually also confirmed these values with a reference laboratory in Europe. Therefore, with our method, you also have the chance to have a better quality control of the mold that you receive. Regarding malts, we have a testimonial, in this case from Avantgarde Malts. Avantgarde Malts is the biggest malt house in Europe. And in 2020, we worked together to test our product and get some feedback from the industry. Quoting directly Winfried Manke, who is the quality director of Avantgarde, he said, the values obtained by using the GlycoSpot method were in the range of plus minus 5 Windisch-Kohlbach. That's the repeatability that I was talking before, which is better than the repeatability R95 as given by Analytica EBC. Another sentence he said, "We have decided to use this method in our routine laboratory. As the method is easy to handle, rapid and precise, we will replace the existing method and will also enhance the frequency of analytical checks." Okay, so now let's have a look at our applications for the brewing sector. And for that, let's talk very briefly about the brewing industry, in which, as I said before, the first step is to actually actually the first step would be to mill the malt, and then afterwards to make a mashing. And there's a subsequent steps all the way to the beer that happen. What is important to say is that this initial step, the mashing step, is essential when it comes to the beer quality. That is, the final body, the final characteristics of the beer, which are mostly defined by the carbohydrate content, will or are defined during the mashing. And that's because the mashing defines both the amount of fermentable sugars, but also the amount of longer chain carbohydrates that give a mouth feel and body to the beer. Therefore, knowing the amylase activity in this mashing step can also help us adjusting the what we would call the mashing step in itself. And just as a reminder for most of you who probably know the process, but the mashing is composed by different steps at different temperature for a different time intervals, in which different enzymes act at those temperatures. However, this is information that was defined or was investigated decades ago, sometimes a couple of centuries ago. So of course it's not a one size fits all, and every beer and every mashing step can have its own features. And that's why we want to help the brewing sector to actually optimize this profile. So with our method, and I will show you in a second, we want to optimize the mashing in terms of time, temperature, and potentially also recipe. And when we talk about recipe, we need to think that nowadays most brewing is done with malt, but not just malt. Many breweries use what is called adjuncts, that is non-germinated or non-malted cereals, like could be unmalted barley and wheat, but also corn, rice, sorghum. Sorghum is very popular in places like Africa, or even spent bread is also used for beer production. At the same time, it's common to add enzymes to supplement or to make sure that there's enough sugar conversion during the mashing. In recent times, there has been several trends of other raw materials to be used in the mashing. That is, for instance, the craft malt and the green malt, both of which can actually include inconsistent diastatic power during the brewing. Green malt, for those who don't know, is actually malt or barley that is being germinated, but which already have some enzymatic activity. So before I mentioned that to get the result of malt, it takes 20 minutes. But actually for brewing, because the extraction of the enzymes are already happening in the wort, it actually takes even less. And you could get the result from the wort collection to the result. It could take 10 minutes to get the result in your app. The steps are very similar to the previous one. You would simply have a dilution step, followed by an incubation with our substrate, followed by a reading in our spectrophotometer series in our app as well. In order to test this product, last year we had a collaborative project with a brew house in southern Chile called Brewhus. Nowadays they renewed the brewery, so it doesn't look like this anymore. And also with Copenhagen University, which have a pilot unit like this, able to produce 1 hectoliter of beer. So they were able to produce 1 hectoliter of beer. In the case of Brewhus, we could upscale it up to 6 hectoliters at that time. And what we did was to, by using a recipe common in the industry and a regime common in the industry, we monitor the enzymatic activity of alpha and beta amylase. And at the same time, we suggested a shorter profile, time temperature profile. In this case, it was only 5 minutes. But what we could see, this is the original beta amylase activity. By suggesting a new profile, what we could achieve is a higher diastatic power during mashing, a slightly higher alpha amylase activity as well, but most importantly, no difference when it comes to sugar composition. That was the first experiment in which we actually used the enzymatic information to reduce the mashing profile. In this case, only 5 minutes in a profile that was around 70 minutes. We continued this research in recent times, and we actually were able to go more ambitious when it comes to time reduction. In this case, we achieved the 20 minutes reduction. And because the total time of operation originally was 60 minutes, that accounts for 1/3 of the time in terms of reduction. We tested that at the University of Copenhagen, and we put all the results together in this scientific paper that you can all read because it's open source. So if you Google this name, you should be able to actually read this paper. But I'm going to show now a few of the main results. For instance, we were able to monitor alpha amylase activity. And here you can see the 2-time temperature profiles. And then you can see here the 20 minutes reduction. And what we could see is that there was a decrease in activity in the last step, and that's why we decided to reduce it. You should note that this was applicable with this specific recipe and with this specific, you can say, plant. But of course, every plant and every recipe is different. So these results were based on the enzymatic activity that we could read. In order to offer you the same time reduction, we should be actually able to read the enzymatic activity that you have. When it comes to diastatic power, we were also able to monitor and actually even increase the diastatic power activity during the mashing. That is because we reduce few degrees in the beta amylase activity, and that allowed us to slow down the degradation of beta amylase, which is actually a very common process at the 65-degree step, also called beta amylase rest or saccharification step. So beta amylase is very thermally unstable or thermosensitive, and therefore slight modifications in beta amylase, and that depends again on your recipe and your plant, slight modifications in this saccharification step could have a huge impact when it comes to plant efficiency and time optimization. We have a look at the final properties because we took this beer and we fermented all the way and we bottle it and we measure the properties at the end. What we can see is that the sugar composition is the same. The free amino nitrogen present in the 2 different profiles was the same. Also, the final beer content. So this is actually the wort content, and the final ABV in the beer was the same for both profiles. The attenuation was also the same. It was around 75%. This you can read in the paper open source that I mentioned before. And what is worth mentioning is that the foam stability was also the same for both profiles. Actually, it was slightly better with the modified profile, but that's discussed in the paper. It could be due to the nature of the malt. But what we observe is that there's no changes or no negative impact on all the properties. We also took this knowledge and we tested with us at Sveneke Brewhus, which is in Bornholm, a small island on the east side of Copenhagen. What we did there was to actually suggest an even higher reduction. At that time, the mashing profile of Sveneke was around 1 hour and 40 minutes. And we suggested a 40 minutes reduction. That is a 40% of the time. And we're talking here about a 33 hectoliter, actually around 40 hectoliter beer production. So here we're talking of a quite big brewery already. And the result of testing the original profile and the profile that was reduced by 40 minutes and which was done based on the enzymatic activity measure on the first mashing performed. The result of it is that the plateau, the color, the protein content, the foam at the end of the fermentation. So the beer properties and the wort properties were exactly the same, even though the time was almost half of the one originally invested. Quoting directly the brewmaster, Jean-Paul, who is very well a brewmaster with a very good reputation worldwide, I would say, he's usually making consultation jobs all around the world. But what Jean-Paul said was that the shorter mashing profile had no negative effect to the beer. The taste, the texture, alcohol content are the same. So summing up, with the GlycoSpot method, what we want is to provide the brewing and the malting sector with a tool to monitor or to measure enzymatic activity. And the purpose of it is to be able for you to measure the activity in all the malts that you receive as a brewers or that you send as a maltsters. We also want to help the brewers to fine-tune their existing recipe or choose a new one. And then we also want to help the brewers to shorten the mashing profile, but without affecting the final product. And that is possible by measuring the enzymatic activity during the mashing. If you as a brewer are interested in to do the same as Jean-Paul and reduce considerably your mashing profile, or you want to know the enzymatic activity of your mashing profile, now you have the opportunity to do so. We can help you measure your wort samples and supply you the alpha and beta amylase activity in a graph like this with the precise numbers and times. In order to do this, we want to make it easy. So we offer you the possibility to send us samples and we will analyze them for you and give you or send you a result and a suggestion for a reduction in mashing time. If you are interested, please contact us. This is my email and this is Jonas' email. Please contact us and we will suggest you what is best to do. The amount of samples and how to ship it, that's something we have done before, and we can define that based on your, you can say, mashing regime and the steps that you do. At the same time, if you would like to do the analysis in-house of the malt or of the wort, we can also help you with a trial period of 30 days, free demo. with that, you would have everything in your hand to see and to understand how easy it is to actually use GlycoSpot method. If you think that is for you, don't hesitate to contact us without any compromise. But we would be very happy to assist you in any step, whether it's the malt, where is the word that you want to measure. So thank you very much for your attention, and I think now it's time for the questions that you might have, and it's also time to go back to me and Jonas in the screen.
Thanks a lot, Raymond. Thanks for an interesting presentation. While you've been busy enlightening us on the many potential uses here, questions have been coming in, and I've been trying to go through them and do a little grouping. I think we can do 5 to 7 questions if you're okay with that, Raymond.
Yes, please.
There's a couple of questions on the different equipment required to carry out or conduct the test, and the first is very specific on the spectrophotometer. Is it possible to run the GlycoSpot test kit with whatever spectrophotometer you have in-house today? It's a combination of 2 questions, so I'm just trying to rephrase it here.
Yes, it is. It is definitely possible. We do have an app which would connect the result by introducing what you read in the spectrophotometer. I think it's a possibility, but of course, what you would lose is the possibility to move the spectrophotometer here and there, because ours is handheld and you would move it close to the production site. But technically, it's possible. I don't know if you would add anything, Jonas, on that.
Well, I obviously agree. I think yes, it's technically possible, and it could be a solution. I think obviously also, as we at GlycoSpot try to make these application-specific methods where it's an all-integrated process, I think some of the benefit is going to be lost, and I think also, in terms of capex and investment here, the Sirius spectrophotometer is comes really at a fraction of the price of a traditional spectrophotometer. So I think it's something to reconsider if that's a concern at least. But let's have the dialogue together and see what's the best solution for you. Well, another staying in the lines of equipment questions here, hardware questions. Another one is the following, Raymond. In our lab, we use a scalar today so that's an automated analyzer to measure both alpha and beta amylases. What would be the advantage of changing to the GlycoSpot methodology or method?
Well, I would say that when it comes to scalar, for what I heard, is not a simple device to use. You need to have certain specialization. It's also what I heard is that the reproducibility depends very much on the skillness of the user. Simply, bubbles can easily enter into scalar and complicate the analysis, whereas in our case, you don't need to worry about that. It's a very simple method. Everyone can use it. You don't need a PhD. You don't need a university degree to run our method. Yeah, basically, I would say that the simplicity and the fact that it doesn't require any hard training to get used to scalar. Probably you would like to add something else, Jonas?
No, I think you covered quite well. I think what I have, probably loops back to what I just said about, buying a Sirius spectrophotometer at a fraction of the cost, whether it's the particular equipment or analyzer mentioned here or some of the, other products in the market. It's I think that's just, it's a part. It should be a part of the dialogue or the consideration, at least, that the traditional automated analyzers are fairly complex pieces of equipment with fairly high costs, unlike what you purchase from us. Obviously, the full-blown automated analyzers have a lot of possibilities. Ours is very designated or built for purpose. That means spectrophotometer is sufficient to run the amylase test, but you cannot use it for, let's say, for measuring free amino nitrogens or something. So I think in that sense, yes, it serves different purposes. I think with my own experience also working with automated analyzers, there's reason to be mindful about when the benefits are really high enough, because in my opinion, at least, it requires to really a significant daily throughput to benefit or to get the benefits from that. Obviously, you get it at some point, but I think the ease of use that I see here with our technology is really a good match in many ways. So yeah,
I can totally agree with you.
Yeah, there's a question here, because I think we both said it during the beginning of the talk, but the fast to implement, what is exactly meant by that? Will you try to take that, Raymond? Otherwise,
so the question is why we talk about fast implementation, or
yeah, what do we mean when we say that the method is fast to implement?
Well, basically because of its simplicity, any customer would take really few tests to actually understand and master the assay. It really takes very few trials to actually get used to it and get to perform it almost at perfection. I would say simplicity is what drives it here.
I totally agree. Obviously, I think that's the point, right? We develop methods that are application specific, in the sense that we also with the calibration and validation is already performed in our lab, and that a traditional quantitative enzyme assays is something that's if you're setting that up from scratch, it's obviously something that can be fairly complex, fairly difficult, and that element is that's really now philosophy, to take that element out of implementation of a new method. So it's really plug and play. You unplug it and you connect with the iPhone, and then you're literally ready to measure from a grained malt, if from a milled malt product, if that's the purpose here. And then of course it requires a few repetitions, a little training, and then you need to of course rely on the large data set that we can provide. The ring trials we have been a part of, that we continue to be a part of. It's the validity and the strength is in the statistics behind those repetitive tests. So I think that's would be my comment. There's another question here: how can you reduce my mashing time, and what is required from me? I think you tried to describe it, Raymond, but maybe a few words.
Yes. So the way you can reduce your mashing is getting to know the enzymatic, the amylase activity during the mashing, alpha and beta amylase. To do that, we need to take samples, and we need to run it with our enzymatic assays. And once you have the profile of alpha and beta amylase activity, then you can see where it makes sense to reduce the activity, which is mostly when there's no enzymatic activity, or it's residual and it's no longer giving any benefit to the wort or to the beer. Yeah. I think it was.
Sorry, Raymond. Yeah.
No. I think that was the question. Yeah.
The reason for interrupting is that we just got a follow-up question here, which is, can you guarantee a time reduction in mashing step? Well, obviously we cannot guarantee, but I think from our experience, many mashing, if we have a focus on the mashing steps in particular, our experience at least is that most mashing steps mashing processes we have been let's say in close encounter with have proven to be sub-optimized or been running for too long time compared to what is actually required. I don't know if you want to.
Yeah, no, it's exactly that. The traditional mashing regimes are, with the quality of the mold that you have nowadays, are way too long. That's a common feedback we heard from many different brewers. The thing is that they don't have the evidence to actually reduce the.
True. So no guarantees, but good indications from our development work and collaborative work and the customers we are talking, daily. So yeah. Raymond, I think two more questions.
Yes.
One is on the, let's say, the jump from brewing to distilling.
Yeah.
The question is the method working for brewing at distilleries, in the distilleries?
Yeah, exactly the same way. It works because in distilleries they also use barley malt or different kind of malts, and they also do a mashing step to maximize even more in distilleries they aim at maximum sugar conversion. So it's even more relevant, I would say, for distilleries.
Yeah, and costs of high diastatic power malt is also, it comes at an elevated cost, so the opportunity to optimize usage of raw material is potentially even higher in the distilling process.
Potentially, yeah.
I think a last question that you're probably going to need also, I'm going to need your help to answer this question here, Raymond, also, is why do I need to measure the samples during the mashing if you already made a study about it? So it comes down to empirical data sets, I guess, but it's I'll leave it to you, Raymond.
No, it's a very good question, right? So if you already have a publication, why measuring? Well, simply because every plan and every recipe and every malt is different from different parts of the world. So if you want to know when or how much you can shorten your profile and you want to know it accurately, the only way is take samples, measure them. There's no one size fits all. You need to measure case by case. There's also harvest variations. So whatever you measure this year, maybe next year is no longer valid. So the answer is that study works for those conditions. It's a general idea that we can reduce the mashing, but how much depends on each case. Yeah.
Very good, Raymond. I think that exhausts the list of questions. And with that, we can conclude on this afternoon, mornings, evening, depending on when you hear this webinar from GlycoSpot. Thanks a lot, Raymond, to you for being with us and taking us through the technical elements in this, because obviously there's a lot of science behind what we do. And thanks to you for listening in. So
thanks everyone for listening. Thanks, Jonas, for hosting.
Yeah, enjoy the rest of the day. Bye.
Bye, everyone.